What if there was a game where we could go backwards in time? Not like time traveling to the past, but instead changing our time direction, so our clock would be running backwards. Perhaps we would be able to see our previous self doing actions we did in the past, but in reverse. And would there be a way to make an actual game out of this idea? My first draft for this video ended up being really overly complicated, so I decided to make this more of a description of an initial idea rather than a full devlog. The first thing we need to implement is a replay feature where the player can see themselves doing their previous actions after they reverse time. First up, we'll need a central clock that keeps track of the game tick and current time direction, so +1 for forwards in time and -1 for backwards in time, and which updates the game tick every frame. Next, we need to code the player's behavior. Every tick the player stores some information, i.e. its position and every actions that are input. Then when time is reversed, we create a copy of the player and send all this information that we've stored to it. This clone just looks at the copy of the Worldline array at the current timestamp and moves to the given position, and the player can continue storing information into their fresh new Worldline. We end up with a system where we can reverse time as many times as we want, and always see clones of ourselves accurately doing whatever we did at the current time. Before we go any further, I thought I'd quickly show the Worldline class. It's pretty simple. It takes in some custom type t and creates an array whose elements are of that type, and time 0 corresponds to halfway along the array. The next thing to do is implement some form of consistent physics, so we can push or explode objects. Physics objects, or rigid bodies as they're called in Godot, don't need to clone themselves, so their logic is slightly different. When we're going forwards in time, each object stores its position every tick into their Worldline array. Then when we go backwards in time, the object follows its own set of previous positions. This type of system is similar to Braid and has been done in some other games too. However, there's one more thing that my idea does. Each object checks to see if all the things they're currently colliding with are the same as the ones they collided with the last time it was at this timestamp. So it checks to see if there are any new collisions or anything different happening compared to when it stored the information into their Worldline array. If there is, then we say that the local area must have changed and therefore that object needs to recalculate its physics. But it's going backwards in time, so we're sort of overriding the past. This system means that objects will do exactly reproducible movement up until the point that something new happens to them. This means that we can go forwards and backwards in time through complex behavior as many times as you want, and things will still happen in exactly the same way every time. But the player can still change the past at any point they wish. First off, this Worldline class is now going to store two things, the object's position as well as a list of all the objects it's currently colliding with. The first thing we do each tick is check if the Worldline already has some information stored in it. If it does, then we're going to do the check I just described to see if something new is occurring nearby. So we can compare the list stored in the Worldline to the list of bodies which are currently colliding with the object. If there are any differences between these two lists, then we say that the universe nearby must have changed enough that this body should recalculate its physics. So we then delete all the elements in the Worldline between the current tick and either the future or past, depending on which way time is going, and set the Worldline being empty flag to true. After we've done this check and potential deletion, if the Worldline being empty flag is true, so either there was nothing in the Worldline or we just declare that the Worldline nearby has changed, then we allow Godot to recalculate the body's physics according to whatever its current velocity is, and we store the new state. However, if the Worldline at this tick still has something in it and our flag is set to false, then we set the current state to be whatever we load in from the Worldline. There's one tiny thing I missed out. I'm actually counting a colliding object as anything which overlaps a small boundary slightly larger than the object. This is because objects at corners are inconsistently detected as colliding by the physics engine. If we didn't do this, then when an object is unexploded back into a building, it might think there are new objects colliding with it, when actually they were just one corner away and should have been initially stored in the Worldline. Using a slightly scaled up Area 3D to count our collisions ensures we are always storing these nearby objects. We can also generalize this system for weapons, bullets, or enemies. We just have to change the list of things we're storing in the Worldline from things colliding with this body to a more general class of objects. In general, this list should denote all the things that have caused the objects to be in its current state. So for the enemy, this might be all the objects it can currently see in its vision. Or for a bullet, it might be how much ammo the weapon it was fired from has in it. But the overall logical flow of the script is the same apart from what we are storing in the Worldline. Perhaps it isn't super clear why I've done this method of time reversal. The main reason is that if we do some set of actions, including reversing time, and then walk away into a corner where we can't affect things anymore, the simulation will propagate both forwards and backwards in time exactly how it would in the film Tenet. The only extra definitions we've added affect how we get to this final game state, but the behaviour of the final state is the same as it would be in the film. This idea is kind of maybe cool, but I think there's one major issue with it: it's unintuitive. We're kind of allowing the player to change the past, but under some weird set of rules that probably aren't very obvious to the player. The main thing that's unintuitive when you're playing this prototype is that the game appears to be unpredictable. One example is that if, whilst a building isn't exploding, the player accidentally touches a block, we get a sort of butterfly effect. The whole building will realise that something has changed and end up kind of imploding into a big mess. Small changes can lead to large differences in the simulation, which isn't great for making the game easily understandable. There's one more confusing thing. Let's say we made this into a simple FPS. What would interesting levels and enemies look like? It's not very clear to me what a good player strategy would be, and therefore I don't really know how to make a good enemy AI. But there's still some light at the end of the tunnel. There's actually a different way to do time reversal that's sort of adjacent to this idea, and I think would probably be a better approach, and that's what I'll be talking about in my next video. I just wanted to discuss the general roadmap for this series. This video and the next one are just initial idea videos, and I'll decide at the end of the next video which general idea I want to go with. Then I'll start a more traditional devlog series. And here's a list of the main things I'd like to make devlogs about. In the description is also a list of all the games I could find that use time reversal and some extra reading about time reversal in films and games. Also, I've listed all the add-ons and open source code I've used to make this idea in another doc. If you have any questions, I'll try my best to answer comments, or you can join the Discord and ask me there.